All right, let's jump right into a question that sounds, well, a little crazy. But I promise you, the answer reveals something absolutely incredible about the digital world we all live in. Today, we're going to figure out what the internet actually weighs.
So yeah, let's just put it out there. What does all of it, every single email, every cat video, every bit and byte of data, what does it all weigh? You know, it's a really fun thought experiment, but it also gets to the very heart of what information really is.
And look, I get it. The question itself sounds ludicrous, right? How on earth can you weigh something that doesn't seem to have a physical form? But by digging into this, we're actually going to unlock a fundamental concept about how our entire digital universe is physically built.
You know, for most of us, the internet feels, well, weightless. We talk about data and emails and videos just existing out there in the cloud. We save things to the cloud, we stream from the cloud. But that very idea, that the internet is some kind of magical floating thing, that's the central myth we are about to completely bust.
Okay, so to figure this out, we have to start somewhere. To find the weight of something, you first have to find the thing itself. So where does the internet physically exist?
So here's the first big surprise. The internet is not a cloud, not even close. It's a colossal worldwide network of actual physical hardware. We're talking millions of servers humming away in these massive data centers, all connected by thousands upon thousands of miles of fiber optic cables running under the ocean. It's the routers, the switches, your modem at home, heck, it's the very device you're using to watch this on right now. Now, here's a super important point. We could, just weigh all that hardware, but that's not what we're asking. That would be like weighing a bookshelf to find the weight of the stories inside the books. What we want is the weight of the data itself, the actual information that all this hardware is storing and moving around.
Okay, so this is where it gets really mind-bending. How can pure information, just ones and zeros, possibly have mass? Well, the answer comes down to something unbelievably tiny.
And here it is, the hero of our whole story, the electron. Yeah, I know it's straight out of high school science, right? But the only thing you really need to remember is this. It's incredibly, incredibly small, but it does have real, actual, measurable mass. And that tiny bit of mass is the key to everything.
So here's how it works in the simplest possible terms. Every single bit of digital data, a 1 or a 0, is stored in a microscopic switch called a transistor. To store a 1, a small group of electrons gets trapped inside a part of that transistor. To represent a 0, those same electrons are released. So the data isn't abstract. It's physically represented by the presence or absence of these tiny particles.
This is a great way to think about it. Imagine a physical book. It has a base weight, right? The paper, the cover, and the ink you print on the pages adds a tiny, tiny bit of extra weight. Well, an e-reader is exactly the same. The device itself has a weight, but when you download a book, your device traps electrons to store that data, and those trapped electrons add a real, if ridiculously small, amount of extra mass.
So now that we know data has mass, because electrons have mass, well, that means we can actually do the math. Let's do a little back-of-the-envelope calculation here and figure this thing out.
First things first, how much data are we even talking about? Well, current estimates put the total amount of data stored across the entire global internet at around 100 zettabytes. I mean, what even is that number? It's a 1 with 23 zeros after it. It is an absolutely astronomical figure. So, to represent all of those ones and zeros that make up 100 zettabytes of information, we have to hold a correspondingly massive, just mind-boggling number of electrons in place across all the servers in the world.
But here's something that really puts that number of electrons into perspective, even before we get to the actual weight. It turns out that the total number of electrons needed to store all that data is about the same as the number of atoms you'd find in a single grain of rice. Wow, so a lot of particles, but in a really, really small conceptual space.
So the calculation itself is actually pretty straightforward, believe it or not. Step 1, we estimate the total data on the internet. Done. Step 2, we calculate the number of electrons needed to store all of it. And finally, step 3, we just multiply that huge number by the known teeny tiny mass of a single electron. All right, drum roll please. After all that physics, all those gigantic numbers, what's the final answer? The total weight of all the data, all the information zipping around the globe and stored in every data center is
About 50 grams. Yep, that's it, 50 grams. It kind of feels surprisingly small, doesn't it?
And to give you a really clear idea of what 50 grams feels like, it's about the weight of one single large strawberry.
Just let that sink in for a minute. Our entire digital civilization, every email ever sent, every photo on social media, every song, every movie, all the world's scientific research and financial data, all of it, together, has the physical mass of a strawberry.
And that just leaves us with one final, kind of fascinating question to ponder. If the physical weight of all our collective digital knowledge is so insignificant, so tiny, what does that say about its true immeasurable value?